So first off, my name is Nick Popoff. I've been in the industry for 36 years. Doug and I go way back. It's interesting, you know. We're kind of, even though everybody's unique, we're all unique, we're all different. But I remember my first interview, I was with the petroleum company, Petro-Canada back then, and they restructured, and of course I was out of a job, much like what's going on in the U.S. these days. You know, if there's a restructuring, you're new, you're gone. So that's what happened to me, and I went looking for a job. And so I was a little bit nervous because, you know, cement company, I was with a petroleum company. I figured a chemical engineer, you know, what the hell has chemistry got to do with cement and concrete? So I went to the library. Who here remembers microfiches? Anybody remember microfiches? Yeah. I went to the library and I started pulling out microfiches of these cement and concrete manuals, and I'm making notes, you know, dicalcium silicate, tricalcium silicate, tricalcium aluminate, the pyroprocessing of clinker, da da da. So I go in for my interview with a bunch of civil engineers at St. Mary's Cement Company. Bill Asselstein was the first one to ask me the question. He said, "So, tell me what cement is." And I said, "Well, it's a combination or a matrix of tricalcium silicates, dicalcium silicates." He goes, "Whoa, whoa, whoa, whoa. I just wanted to know if you knew the difference between cement and concrete." And that's how my career started. So I'm going to, I still don't know the difference. But that's okay. I fooled him for 36 years. It's amazing. I'm going to go through some of the just a few things on the specifications on ASR, sulfate attack, and other stuff, because that's what Larry said I should speak on. It wasn't my title of choice, but really my title of choice would be we're problem solvers. That's where, you know, Doug and I have really established our relationship. So if there's a solution, let's do it right. So Doug and I go back, and I'm thinking it was I started in '89, so it was 1994. Doug said to me, "Hey, do you like fishing?" And I said, "No, I really don't like fishing that much." And he goes, "Oh, well, a good buddy of mine, you know, from Lafarge," was it Dave Scott at the time? It was Dave Scott, who said, "Dave Scott and I are going to go fishing up at my place, and you should come along." And I went, "Well, okay, not really into it. Let me think about it." So I called him, you know, like a week later. And I said, "So you going fishing?" He goes, "Dave canceled on me." I said, "Oh, who are you going with?" He goes, "Nobody, I'm going to be by myself." So I felt sorry for Doug. And so I decided to go fishing with Doug. And we had a good time. I mean, as you can tell, we caught lots of fish. But one of the things I noticed was that's Doug's garage, you know, for his boats. And when I went to go close the garage door, the one on the left here, the latch wasn't lining up with where the bolt was coming through. So I said, "Doug, I can't get this thing to work." And he comes out, he goes, "Hang on, I'll be right back." He goes in, he gets a screw gun, he comes out, and he moves one of those latches down about 1/2 inch so it lines up. And I said, "What the hell kind of fix is that?" And he goes, "Well, that's what I always do." And you can see over the years, they were progressively going lower and lower and lower. And the problem was, if I can get my pointer out, the problem was in the middle here, this thing was sagging. The roof was actually sagging in, and everything was sagging in. And I noticed when we went in there, everything was rotting from underneath, and it was a dirt floor and everything else. I said, "Doug, I mean, we can't continue to do this. This is ridiculous." And he goes, "Yeah, I know, but I'll get around to it." Now, everybody knows Doug, right? We know how busy he is. So when he goes to his camp, I think for the first, until the pandemic, you probably only spent like 2 or 3 weeks there every year. And he's not going to get all these projects done. I'll get into that in just a little bit. But so what we decided to do is we actually poured some concrete there. Now, Doug, being a civil engineer, didn't really follow the cross-sectional area for steel reinforcement. because what we were using were single steel sash from windows that he had taken from some project, God knows where. And Barb probably told him to take it up to camp and get it out of my damn garage, more than likely. So we used other steel bits and pieces, things that we found. I think we had transmission parts and things like that too. And we poured concrete, and then, of course, we went fishing, because that's what you like to do. The priority is fishing. This other stuff, takes on life of its own. So he's a busy guy. So we made a deal. The deal was, we go fishing. I can't fish all day. I don't hate fish that much. I do like fish, and I like the outdoors, and I like his company, but I can't spend all day in a boat. I said, why don't we go in the morning? We'll pick a project every year, and we'll finish that project, and then, we'll go fishing in the afternoon. If we need to work the next day, we'll do the same thing. We'll take 4 or 5 hours, 6 hours in the afternoon, and we'll do it. So this was Larry Sutter at the end of Doug's dock. As you can see, some damage. Well, that was another weekend that we went. We tore it apart, and there's Doug, smiling Doug. There's Steve Parks sitting there. And there's the final product, and there's Larry on a finished product. So another little project. I'm not going to show the project of Parks and I putting new tile down in the laundry room. I don't have that one, and I don't have the lawnmower that I gave you, one of two, because they keep breaking. I guess they're my old lawnmowers. So truth be told, they're not the greatest anyhow. And then there was a year that Doug bought a new boat. And it wouldn't fit in the garage. So what do we have to do? You got to add on to the garage. So there we were talking about the plans on how to do this. And I discovered one thing. Any Northern Ontario folks here? Anybody familiar with black flies? Did you know that they don't die in the heat? Typically, black flies come out in May, and they bite the hell out of you, to the point where we have to make sure that we're fully covered and taped up, and we have nets on. But one thing that we found out when we were digging here is they actually go hibernating in the soil. And so when they come, this was a fall prep trip, right? I think this was fall. So we thought the black flies die off in the heat, but they don't. They actually go into the soil to keep their temperatures at a certain temperature. And then if you disturb it, they come out and they bite the hell out of you. And then this is the spring where we poured the slab. And then this was a summer trip where Larry and, with his family and me and my family and Doug and I, we ended up putting on the extra garage that would accommodate the new boat. And then there's the time that we cleaned up the garage without Doug around, but that's a sore spot with Doug, because we actually we didn't accidentally burn things. We burned a lot of stuff that he had collected, and apparently he saw them on the fire pit when we took a picture of the fire pit, and he saw that we had burned some of his cherished items. So he won't let us go up there alone anymore. And then there was this is the last one. We needed power to the outsheds. And so we were good at and you see Parks here with the net on. We needed power to the outshed, so there's Doug and Parks digging the trench, and I brought up my electrician buddy who also likes to fish. So there's value in teamwork, and there's value in problem solving, because anytime we had a problem, we fix things, and we enjoy doing it. We actually enjoy doing it because Doug's a great guy. We like to spend time in the boat. We actually talk about a lot of this stuff when we're fishing in a boat. And then, of course, there's the teasing and the other stuff that happens, goes along with it. But so I'm going to go back. I'm going to go back on topic. What was ASR? I think, and sulfates. I forgot. Anyhow, back to 1990, ASR was a hot button, and really not so much sulfates at the time. The subcommittee for AAR in Canadian specs was under the cement specifications, because everybody related ASR reactivity to alkalis. And where were the alkalis coming from? They're coming from cement. So therefore, the cement guys, the subcommittee worked under the cement, the subcommittee for AAR worked under the cement specs. And then they migrated over to the concrete specs, because with Doug's influence and other people, they said, well, you know, it's not really just the alkalis, it really is an aggregate issue. It's an aggregate reactivity issue, so it really belongs in concrete and aggregate. So they migrated over. They were kind of on their own for a bit, and the CSA A3000 and A23 didn't really work at the same, you know, same location at the same time. So what they ended up doing is they end up with some, you know, some really good advancements in the specifications. And back then it was Benoit Fournier, Patty, Gretton Ballou, Mike Thomas, Rogers, and of course Doug, some pretty prominent guys. There were 2 cement producers in the room and 1 aggregate guy in the room. And, but through the consensus process at CSA, we ended up, you know, developing some pretty good specifications. We also had you know, as luck would have it, we had the Spratt aggregate as a pretty good control aggregate in Canada. So back then, I remember talking to Doug. I can't remember whether it was in a boat or not, I don't know. But anyhow, Doug was telling me about this, you know, South African test for accelerated mortar bars. Up until that point, the C227 test was the only test that they used in mitigating or preventing AAR. So one of the things that Doug was mentioning, I think it was Doug and Chris, they said, what about this new test method? So the 90s were a time of fast changes in AAR. I'm not sure if you guys remember the timeline, but in 91, Ken Met and Kingston, I see Ben walked in the room too, Ken Met and Chris Rogers in Kingston developed their exposure sites. In 94, they developed the 25A accelerated mortar bar test, and then ASTM followed suit. Then they came up with a concrete prism test in 2000, kind of to validate, you know, what was going on in AAR, but we weren't doing a lot of mitigation work at that point. That came in 2000, and CSA basically took the lead on that. At the same time they developed the concrete prism test, they were also doing SCM replacements and showing mitigation with alkali silica reactivity in the accelerated mortar bar test. And then, of course, ASTM followed suit in 2004. And then, of course, in 2000, the Canadian CSA also had the protocol for mitigating ASR. In 27A, we call it in CSA A23.2-27A, which later became 1778. So, you know, over a 10-year period, you had the evolution of, you know, accelerated testing, concrete prism testing, accelerated with mitigation, and then you had the template for mitigating, which was really, I mean, it's quite impressive. But we had an impressive group of people working on it. I mean, Doug was one of the leaders in that group. So the only issue I had with it, being a cement producer, oh, did I mention I'm a cement producer? We actually, one of our cements had a high alkali content. It was about 1.0. Always had a 1.0, more than 1.0. So I said to Doug, this doesn't work. Why is the limit of 1.0 in the specifications? And he said, well, I guess in order, if we want to change that, we're going to have to do some testing with it. So we did, and I think, you know, Doug did it with Ben, and I think maybe Mike Thomas was involved. I got it coming up here. But we had a few producers with high alkali Portland cements. We knew that there was mitigation in, you know, without SCMs, you're getting alkali silica reactivity, some. You know, but you know that you could mitigate it with SCMs. So we did a 5-year study, and that led to the changes that we currently have in our specifications. Before, it has to be the alkali content of the cements in, you know, to use 1778 or the equivalent to it, they had to be below 1.0. And basically, it was Doug, Ben, Kerry, and Raymond Chevrier. Who came up with mitigating alkali silica reaction when using high alkali cement. So we struggled with it, we worked at it, and through teamwork, you know, we're problem solvers, right? So where are we now? Currently the focus is really off the alkalis and more on the matrix and the role of SCMs. We know that calcium hydroxide has a more significant role in ASR now. We know that you can get good performance with high alkali SCMs and high alkali cements if you use the performance testing that we've got laid out. And it seems to be working. Now there's a current discussion on whether accelerated mortar bar testing or concrete prism testing is a more relevant test, but again, Doug, if he hangs around the next 10 years working in the industry, maybe we'll put that one to bed. On sulfate resistance, because Larry asked me to talk on this too, but people are going to expand on it. When we brought in Portland, this really became prominent when we brought in Portland limestone cements. I was chair of A3000. It was the Niagara Falls meetings, and it was proposed that we include Portland limestone cements in our specification. We got to do some work on it. So strength, workability were one thing, but someone had raised the issue of potential sulfate resistance or potential sulfate problems. So Doug we didn't have access to the Bureau of Rec exposure site in the United States. They had since demolished that. But there was one, and Doug remembered this somehow. He remembers things. It was brought up earlier on how he seems to know where everything is, even though it's in complete shambles and disheveled. He seems to know where everything is. And he said, yeah, there's this Gardner Dam exposure site in Edmonton, near Edmonton. And we're going, I've never heard of it. And he said, well, we can do a survey of whether the current specifications are relevant to mitigating sulfate expansion and deterioration due to sulfates. So Mike Thomas and Doug Hooton went out there. Basically, they unearthed a whole bunch of specimens that have been out there for 50 years. And we basically wanted to see whether the current 452 or 5A test was relevant for Portland limestone cements, not necessarily for using SCMs, but just the cements on their own, whether there was a similarity in what the findings were. And basically, at the end of the day, it came down to, I believe, yes, there's some element of the cements themselves, but mostly concrete. The strength water cement ratio will give you good durability, assuming your cements are quote unquote reasonable. So it took the pressure away from the chemistry of it, and so that's where we wanted to and that's where we needed to go at first, and then of course there's always the improvement of the test, right? So we're currently evaluating at the industry, and Doug's leading this one too. The A8 or C1012 test. We're looking at the relevance of that to field and exposure. And then, of course, there's a minibar test, which Doug is doing the research on, even years and years later. He's still at it on the sulfate side of things, and he chairs the sulfate task or subcommittee at CSA as well. So some of the reports that came out of the work, very, very relevant. This was for Canada. And then the sulfate resistance of mortar and concrete produced with Portland limestone cement was written. The bulletin was written by Doug and Mike. And then again, the sulfate resistance of mortar and concrete produced with Portland limestone cement and SCMs for CSA as well. So they work both sides of the border. They're considered experts in ASR and sulfate resistance, and it's like the old commercial, when Doug speaks, people listen, and they really do. So the last thing that I wanted to say, this is the other stuff that Larry said I could put in there. So this is the other stuff that I'm putting in there. One of the things that I know that Doug has been really strong and a true believer is performance of concrete in situ, in service. And he rode that hard. There was a group at CSA that worked very, very hard on getting performance specifications, depending on the exposure class. And I've highlighted one of them here. This is bridge deck concrete. Basically, the exposure is called a C1. C2 is your typical, driveway, flat work exposed to de-icing chemicals, freeze-thaw and de-icing chemicals. So the minimum requirement is certain strength, maximum water cement ratio. Again, for A1, it's maximum water cement ratio. But then we brought in, coulombs, rapid chloride permeability testing. That is actually, it's part of the, if you look at any sort of modeling for predictive life performance and longevity, permeability is critical. What's in pore solution? Are you tying up, pore solution? Are you densifying your concrete matrix? So important. And I don't know why we can't get there on the U.S. side. I don't know why we can't get consensus, but that's going to be my last presentation in the last session. Again, Larry asked me to speak twice, so hopefully you guys will actually come to that. Anyhow, so I think this is one of your legacies, and if you're able to do it on the U.S. side, that'd be absolutely incredible, because that's one thing, and that's my one pet peeve with in Canada we got it right, and we're continuing to improve it. Savio and Andrea spoke earlier on about resistivity, bulk resistivity. We're working at CSA to actually bring that more efficient, faster test in, so it's not as laborious as the C1012 test or the I don't even know the number. What is it? So it's not as difficult as that test. It's a lot easier, and we found a pretty good relationship for it. I think that's going to be our next step moving forward at CSA. So performance specification, we need to move ahead. We have to collaborate together, industry, academia, end users, and we do. I see Hannah walked in the room. There's one of the users, and we work together to achieve these things, because at the end of the day, it's concrete, stupid. I mean, honestly, it's not that difficult. We just have to understand that we got a product. Cement is concrete to me, but don't tell my boss that. Anyhow, we have to make sure that we're leaving a good legacy for those behind us. Anyhow, thank you.